All right, now let's take a look at one of my least favorite subjects, and that subject is chatter. I don't like chatter. Chatter's tough. In fact, most of my fellow grinders, they'll tell you, when you get into chatter, you're in for an adventure. And even Frederick Winslow Taylor, the godfather of production engineering, said way back in 1906, chatter is the most obscure and delicate of all problems facing the machinist, and probably no rules or formulae can be devised which will accurately guide the machinist in taking the maximum cuts and speeds possible without producing chatter. And of all the difficulties met with by the machinist in cutting metals, the causes for the chatter of the tool are perhaps the most obscure and difficult to ascertain. And in many cases, the remedy is to only be found after trying almost at random half a dozen experiments. Now, having said that, let's take a look at one type of chatter, and that is called self-excited chatter. And let's touch briefly on even just one aspect of self-excited chatter. So in self-excited chatter, what we have is a wheel. And let's say we have a workpiece, and let's say we're doing surface grinding. So we're doing surface grinding, and here comes my wheel. Now this wheel likes to bounce up and down at some certain natural frequency. If you got a Jones and Shipman 540 surface grinder, the natural frequency is something like 500 hertz. So that spindle likes to go boing, 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 500 boings a second, or 500 bounces a second, or 500 hertz. The natural frequency of this guy. It's going to bounce up and down. If the force is big, he's more likely to bounce up and down. If you have an inconsistent normal force pushing back, you're going to be more likely to bounce up and down as an excitation source. But this guy is going to go boing, 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 boing. Now, when that workpiece is traversing, and this guy's going boing, 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 and the workpiece is going zzz. So now what we're getting is a distance between chatter marks. And it's a very simple calculation. You figure out what your traverse velocity is in millimeters per second. You figure out what your boing frequency is in boings per second. And you say millimeters per second divided by boings per second will give you millimeters per boing. Now, so here's my wheel. It's going boing, 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 boing in a cylindrical plunge operation. Every wheel has a natural frequency. This guy might have a natural frequency of 100 bounces per second or 100 boings per second. But it can get complicated. A wheel spindle assembly that's stiff will boing and bounce at a high frequency. One that's not stiff will boing and bounce at a lower frequency. It's one of the things that makes chatter more common in cylindrical ID grinding, because it's not very stiff. If you have the same stiffness but a small wheel, your boing frequency is going to be higher because you have less mass. If you've ever studied vibrations, frequency is the square root of stiffness divided by mass, etc., etc. So that what makes it tricky is trying to figure out what that bounce or boing frequency is tough because it might be changing as the wheel wears away. Now, having said all that, if we get chatter, or if we have some chatter or a little bit of chatter, it would be nice if we could have those chatter marks such that the chatter amplitude is small. Now, we've talked about the chatter frequency. This guy's moving in this direction. This guy's going boing, 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 boing at a certain speed. And we will either end up with scallops or we will end up with waves. So let's think about this. Here are some chatter marks on a cylindrical workpiece. Here we have scallop marks on a surface ground workpiece. Here we have a white light interferometer photo of a chattered workpiece, and you can see the scallops there in the chattered workpiece. Now, it would be nice if those chatter marks were attenuated. And we can attenuate that by having a arc length that's longer than the distance between chatter marks. Or another way to look at it is, imagine you went out in the ocean, you got in a small little boat, you're going to go up and down and up and down and up and down with the waves. Imagine you went out in the ocean, you got a very long boat. Well, now you're going to be hitting several waves at the same time. So what does that mean? It has to do with the distance between chatter marks and the arc length. If the distance between chatter marks is long and the arc length is short, we're going to get waves. This is all very simplified. If the distance between chatter marks is short or the arc length is long, we're going to get some scalloping effect. So when do we get scalloping effect? So let's take a look at this. Now, we've got a wheel, and that wheel is going boing, 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 up and down as it traverses the workpiece. It's going to follow a sine wave function. If my arc length is small, I'm going to end up with a sine wave function on my workpiece. I'm going to end up with waves on my workpiece. And on some cylindrical grinding operations, if you do a tally round profile or a roundness profile, you will see a workpiece that has flowery waves like that. Okay? But what if our arc length is long or the distance between chatter marks is small? Now what's going to happen is successive bounces of the wheel are going to hit previous waves, and we're not going to get this type of shape on the workpiece. We are going to get this type of shape on the workpiece. The wheel's going to go like that, and we are going to end up with scallop marks. And if we end up with scallop marks on the workpiece, we are going to end up with a smaller height of those chatter marks. And it's also going to do some other things too that gets a little more complicated, but we're going to get what's called contact filtering, which is also going to help the chatter. So, how do we pull this off? How do we get it so that we get some scalloping effect and not just the wave effect? So if we want scallop effect and not just the wave effect, what we want is a long arc length on our wheel. We want this guy to be long. What we want is a short distance between chatter marks. So we want that those boing, 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 boing chatter marks to be close together. So let's take those one at a time. If my wheel is going boing, 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 and my workpiece is going like this, and I want those boing, 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 boing marks to be close together, I can do two things. I can increase my boing frequency, boing, 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 instead of boing, 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 boing. So if this guy's going boing, 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 they're going to be close together. If this guy's going boing, 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 they're going to be far apart. Not an easy thing to do. You've got to have a stiffer spindle or a lighter wheel, probably a stiffer spindle. That gets difficult. What we can also do is slow down the traverse velocity of our workpiece. So instead of going, we're going, and now we're putting those chatter marks closer together. So that's number one. Number two is, if we want our arc length to be longer, there's my wheel. We want that arc length to be longer. We can either have a bigger wheel diameter, which is not easy to do, or we can take a deeper depth of cut, which is easier to do, gives us a longer arc length. So, what does that mean? If you have self-excited chatter, one thing to try is to take a deeper cut at a slower feed rate. So instead of taking fast and shallow cuts, go doink, slow and deep. So if you have a choice between grinding fast and shallow or grinding slow and deep, you're probably, not always, but probably going to help yourself in terms of chatter by going slow and deep instead of going fast and shallow. Now, there are other issues with going slow and deep. Your risk of burn might increase, your self-sharpening of your wheel will not be as good. But at least in terms of self-excited chatter, you may help your cause by taking a deeper cut at a slower speed.